Hi, everybody. So pleased to be here. So I've actually had the honour of having a hand in putting together some of the programme for the education and HR aspects of the festival. And I'm really excited to be moderating this first panel and set of presentations on personalised AI learning. I used to be a teacher, and then I began exploring the world, looking for the future of education. And a huge part of that future, I'm convinced, will be the role that AI will play in equipping teachers and students with tools to learn more than they have before, to learn in different spaces at a different pace, in potentially a more individualized way. And it's that topic we're going to be digging into today. So just before we jump in, a little overview of the session. We're going to hear 3 presentations from our 3 brilliant presenters, which will last for around 20 minutes in total, before then going into a 25-minute panel discussion, where I'll be asking them some questions about the role of AI in education and personalization, about what that means for now in our current situation. And then, of course, there'll be an opportunity to get together in the breakout room afterwards. But with no further ado, I'd like to introduce our 3 panelists for today. I'll do a little introduction of each one, and then we'll hear from each of them. So we're joined by Joel Hellermark today, who's the founder and CEO of Sana Labs, which is one of the leading AI companies focused on education in the world. I've had the fortune to interview Joel in the past, and he's always interesting, thoughtful, and inspiring on the future of education. He taught himself to code when he was 13. He founded his first company at 16 and has been named one of the most promising business people in Sweden a couple of years ago, one of the top 10 people under 35 changing the world by The Guardian last year. So we're very, very fortunate to be hearing from him. And Joel, I'll hand it over to you now.
Fantastic. Thank you so much for having me. And as mentioned, I'm Joel, founder and CEO of Sana Labs. At Sana Labs, we're a group of researchers and engineers with backgrounds ranging from Google AI to Spotify, as well as Imperial College, working on how can we bring the benefits of machine learning to human learning. And also, just as we kick it off, can you see my screen? So you should be able to see my screen now. Brilliant. Then let's get started. So a quick introduction about Sana Labs. We're focused on bringing the benefits of machine learning to human learning. And we provide an adaptive learning platform used by Fortune 500s, some of the world's leading health systems and pharma companies to personalize upskilling, reskilling, and skilling of their employees. And one of the case studies that I wanted to walk you through today was Project Florence, an initiative we founded around bringing personalized learning to the upskilling of health workers in the light of COVID-19. We partnered with some of the leading health systems, such as Mount Sinai and Karolinska Institute, as well as institutions and teachers from the New York Academy of Sciences and Arizona State University to bring a personalized learning solution to this market the past few weeks. And as we start, some of the key hurdles that the industry was facing was the profound shortage of nurses and ICU nurses, as well as respiratory therapists that could help in the treatment as well as prevention of COVID-19. So the health system saw an immense need to effectively upskill their associates and treat patients more effectively. In the light of that, we developed a platform that combined the latest from AI and adaptive learning, as well as really high quality content from Arizona State University and others to provide this kind of personalized learning solution. What the system would start with was an adaptive assessment that would measure the status quo, the current knowledge of the nurse. And why this was absolutely critical was because the nurses started at very different knowledge levels. Some already knew 20% of the curriculum. Others might have not mastered any of the core concepts related to treating COVID-19 patients, and others 60%. So by effectively identifying their current knowledge level, we could subsequently introduce a personalized curriculum. The subsequent aspect was then serving up just the right resources that the nurses needed in real time and based on their individual skills gaps. So by applying AI to the task, we could predict what were the areas the nurse would have the greatest difficulties, and then serve up the resources that were predicted to have the most impact addressing those specific needs. Finally, another key aspect around learning, as we know, is memory. And memory plays a central role in learning. And in this particular case, it was absolutely critical that the nurses not only mastered the material, but equally retained it over time. So what you can see here on the right are the forgetting curves of various concepts. And what the system would do is model how these concepts would be forgotten over time and review them until the nurse has retained them in long-term memory. And as a function of this, then the administrators could get real-time insights into what are the strengths and what are the gaps of their organizations, track what are the skills gaps that are keeping the nurses from treating the patients effectively, and provide targeted interventions that will help them master these concepts over time. What this then resulted in was a completely personalized learning path for each individual nurse that served up just the right material in real time until they have demonstrated mastery. Not only helping them go through the curriculum in half the time, but also remember it three times longer. And the feedback we received from this was overwhelmingly positive, with comments ranging from, I really appreciate the AI modules and the AI approach to customize the training, to the repetition helps with retention, which is very helpful for us who are patient facing, as well as this is a high quality and meaningful product that makes a direct impact. And that was also illustrated in the customer satisfaction scores when we measured this. So on average, LMSs have a customer satisfaction score of -25. And with this particular product, we got a customer satisfaction score of over 80, which was unheard of for this market. And to date, we've now trained over 50,000 health workers who have been provided with this kind of personalized learning approach to upskilling them on the critical concepts on the treatment and prevention of COVID-19. And hopefully this not only has effects in securing the safety of the nurses, but equally on improving the treatment of COVID-19 patients and ultimately helping save lives. So we're very passionate about how these personalized learning programs can be implemented in critical scenarios, as the one we had with COVID-19, to drive improved learning outcomes, helping nurses learn faster while remembering it longer, and ultimately staying more engaged with the product. So that's some of the insights that we derived from applying this personalized learning to the current COVID-19 situation. I'm keen to discuss this further in the upcoming Q&A.
Thank you so much, Joel. Yes, looking forward to exploring lots of those questions in a second. So having heard from Joel, we'll now go on to our second presenter, who is Conor O'Sullivan, who is the co-founder and CEO of Adaptemy, which is a provider of adaptive learning technologies to some of the leading education companies around the world and to governments since 2015. He leads a research team that's published over 20 papers in the application of AI technologies to learning, and has contributed to other things in EdTech investment and many others. And I cannot wait to hear from you, Conor. So I'll hand you over now for your 6 minutes.
Okay, thank you very much, Alex. So I'm Conor O'Sullivan, CEO at Adaptemy. Now, we provide intelligent learning solutions to some of the world's leading education companies, online tutoring companies, ministries of education, e-learning companies. And what we do is not so much a point solution of adaptive learning as the whole process, tools, as well as the adaptive learning platform to enable them to build products that have these AI capabilities in them. So as I said, we have a technology that enables our partners to build a wide variety of learning experiences. And the case I'm going to look at today, it's adaptive exercising. It's still the most popular implementation of these technologies. And I suppose I'll take you through some of the things that work well, the things that, the things that work really well in adaptive learning, and also the things we still struggle with. I think, so I suppose Joel gave a very good idea of what are the ideas in adaptive learning. Just one key thing before we move forward is this idea of modeling learning. So you have this idea that adaptive learning is anything that adjusts the learning experience based on what happened. But really the power of AI and adaptive learning now is all around creating a model of the learner. So independent of the product, you start to really have something that you can validate, that you can inspect, and then talk through with your partner. So what is the model? The model, first of all, obviously is everything that we think that the learner knows or doesn't know, along with some idea of the accuracy, how well we estimate that. But it's also many other things, their learning preferences, their patterns, their behaviors, other things like, are they a very self-directed learner? What is their idea of self-efficacy? It's not tied to any product or content, and it's typically defined against a curriculum and has a process of keeping itself up to date. So at any moment, it's modeling the forgetting and also, let's say, motivation, the engagement of the student. In adaptive learning systems, there are typically three models: a model of the curriculum, a model of the content, a model of the learner. The curriculum is everything we hope the learner will acquire, all the knowledge. And you've probably seen visualizations like this before. So not just a list of all the learning objectives, but the way they are related to each other and the weightings of the relationships between all these things. Then the model itself, it updates after every piece of data. So the partner's learning platform will stream learning data to us. Then with every piece of data, we then update our estimate of the learner, their idea of the learner, and then also update everything else about their learner model, and then also how much they forget. What this does is it provides really powerful tools then for product designers or our partners to create learning products. What type of things can they do, or what type of strategies can they use? First of all, sequencing questions within an exercise, managing detecting attention, disengagement, intervening, reinforcing learning, so memory with spaced interleave practice, promoting learner agency by giving really good feedback and learner reflection, recommending learning paths to build mastery, recommending concepts, and then recommending content objects. So these are really important strategies that we can provide to our learner product partners, and then they can all be measured independently. So you're measuring the accuracy of your models and then the effectiveness of each strategy. And we've seen over time, of course, as you get more and more data, the strategies and the models can be more accurate and more effective. And just finally, just to wrap up by saying that this approach, what makes this approach of using AI in education so different is that we can't just provide an AI-powered experience to learners, because we have a lot of stakeholders to bring on the journey with us. The chief learning officers of these education companies, ministries of education, product designers, but also teachers. So teachers need to know how these are working to agree or change the learning strategies, and then to be a part of, especially in the K-12 and in the primary and secondary school sector, be part of designing the learning experience for the students. Thank you.
Thanks so much, Conor. Again, lots to dig into during the discussion. And so just on to our final presenter before we get into the panel discussion. I'm really excited that we're joined by Jessica White, who's a senior consultant at EDUvation, which supports edtech startups with a variety of different services. She has been an academic consultant at McGraw-Hill Education, working with teachers and product designers to bridge that gap of understanding, which leads to the successful application of edtech products in the classroom. She's been a mentor for UCL's Educate and won an innovation prize for an AI education startup at Oxford. So over to you, Jessica. Hi, Jessica. Sorry, you've been muted for the first 30 seconds. We'll start the time again, don't worry. You can have the full 6 minutes still. There you go, we can hear you now.
Okay. Okay. I'll just share my screen. So, okay. So we'll start again. I hope that you can hear me okay and that you can see my screen. So as we heard from Joel and Conor, then there are many different ways to look at personalized AI from the engineering perspective, from the teacher, the product perspective. I'm coming from a social science background and, as Alex said, a former teacher. And currently I'm working with different companies through EDUvation and previously that have used adaptive learning in AI systems. So I'd like to give you just a brief overview of some of those. And this includes those that are based in Singapore, as well as McGraw-Hill Education, one that's actually in Sweden, and Stabile that's based in Germany, that was based on a research and development writing tool, as well as Google Arts and Culture. So briefly, in a democracy, before you teach what you know what your students know. This is actually from Paulo Freire, and it's the idea that you can actually find a way to look into what your students are, what their level of knowledge is before you actually then go into the teaching process. And I think that we have that capability now with adaptive learning systems and AI to really get the full picture, or rather as much more than we had before, and then to discuss that with the students so that we can build more optimal learning paths and learning journeys for them. So Apple's is a personalized learning diagnostic system, particularly for primary science. And at the moment, it's out in Singapore, in the US, in Europe, and we've actually got a pilot school in the UK. And teachers are really having problem areas about determining where their level is. And so it's a diagnostic tool which particularly looks at what the students know by providing them with questions. And then going on to giving them learning assets based on how they have answered and their time on the task. The teachers are able to actually then look at the specific learning gaps of each individual student and then develop each student is able to have a learning path for a different mastery level. So the student has a chance to actually look at their areas of weakness, whereas the teacher is able to clearly diagnose where the student needs help. And each set of learning content is specifically for that student once the diagnostic has been taken. So this gives, especially in these times when the students are at home, a real learning journey which they can do both on their own, but also we invite the teachers to get involved with actually planning how, for example, you can see here, this is a mastery document which enables the teacher to see which are the top 5 challenging learning assets from the students. And from that, then the teacher can actually group the students within a particular peer group, or they can bring in students that are having some ease of access or ease with the learning assets to actually develop a more peer-to-peer learning between the students themselves. So it's that granular level of detail through this adaptive learning that gives both the students and the teachers those abilities to actually plan their lessons in a more effective way. So going on to McGraw-Hill, which is a slightly different type of adaptive learning. So it's using small data, which is basically the assignment scores, the time on task, and the progression in the adaptive learning environment. And again, there is opportunities with that to then do the flipped classroom approach and make sure that the instructor is helping and supporting rather than actually doing the baseline knowledge, which is really great for the teachers themselves, because not every teacher wants to teach the baseline knowledge and wants to actually go into the higher level concepts. So this can be done through the smart book, and then there's the metacognitive layer, which is part of the adaptive learning process, which gives that more effective state about the students' emotions, how they feel, how confident they feel. So it's the actual question and the confidence as well. And then following that, the actual what's underneath or what's in the back end is that every Learn Smart title has a particular chapter, which enables the chapters to have learning objectives, and the learning objectives have about 50 to 100 per chapter. And this, as the students go through the chapters, then they're able to, I'm a bit behind with the animation there, they're able to understand each particular learning objective through different probes, and there are about 2 to 5 per learning objective, 2 to 5 probes per learning objective. So what's really good about this is that it builds from the core to the actual conceptual, and then it reinforces the learning objective through the different probes. And those probes are done through different types of questions, such as true, false, or statement-based questions, but then also fill in the gaps. Okay, I'll just go through the animation a bit quickly because I'm realizing the time there. Okay. So as you can see, then the probes are connected. And that's just an example of the true, false questions and the ranking and the fill in the blank questions. So you've got your core, builds on the core, and the conceptual. And of course, the learning objectives are all related to each other, so it builds a conceptual framework of the student so that the machine can understand and build up that conceptual understanding of the student. Okay, so just moving briefly on to Hippocampus, it's from Sweden. Slightly different, using neural networks. The problem is that there is so much documentation for medical doctors, for medical students rather, to learn, that it's important to all have it in one particular place, which is on the Hippocampus platform. This is actually the time that the students spend on the platform and the time that they spend actually reading a particular learning asset. And then there is also a diagnostic after they've read the learning asset, which enables them to test their knowledge. And as you can see in the top graphic, then it's based on the Ebbinghaus forgetting curve. So the questions and the diagnostics enable the student to retain that knowledge over a period of time. And you can see a more detailed version here, which enables the students to keep improving their retention, their memory through this combination of both the reading and the analytics behind the reading, which is the time on the task and how they've answered the question. And then also the way in which the adaptive learning is able to bring back the learning assets at exactly the right time, at the moment that the student is about to forget. So just briefly to say that the benefits are that it can have better grades and it reduces remediation time, and that learning data forms the basis of insights and learning plans. But there are challenges to do with transparency and explainable AI, but also students can be profiled as at risk. So students need to be understood within their social context. I recognize that I'm running out of time, so I will probably just have one more where I talk quickly about the personalized handwriting, which is a slightly different thing, which is using motion sensors. So that's also a way to detect and adapt to the learner. But here, then, the AI is not quite developed for inside the pen because the microprocessing is not as powerful yet, although Google have brought out a recent microprocessor that enables AI to be on the pen, but the AI is done in the tablet. So the pen delivers the writing through the pen to the tablet, and then the student is able to recognize their own handwriting and look at things like letter formation, get real-time feedback on tempo, rhythm, and pressure so that they can improve their handwriting for memory and retention. So I'm actually going to stop there because I have run out of time, but I'm just going to end with mistakes are portals of discovery. So we need to encourage these mistakes rather than try and make our students perfect. And that's a combination of working with the students and the teachers in combination with AI and adaptive learning. So please do get in touch if you have any questions, and I'm happy to answer the questions in the panel.
Fantastic. Thanks so much, Jessica. And now we'll be joined back in a panel discussion by Joel, Conor, and Jessica, where we'll be able to follow up with a couple of questions on their presentations for the next just a bit more than 15 minutes. So thank you all for an incredible whistle-stop tour of the potential of AI in personalizing learning. And I have some follow-up questions, but you should also feel free to pick up on themes from one another's talks if you would like to. So take these questions where you would like to. But I want to start with you, Joel. I love this idea of learning faster and engaging longer. That's something I would have loved to have experienced with my students when I was a teacher. When you think about the potential benefits of AI and personalization, where is the real extra power coming in? And are there particular areas where this kind of technology is more applicable than others? You talk a lot about skills, for example.
Yes, indeed. I think one of the core areas is, and which is sort of illustrated in most educational research, is the one around proximal difficulty. So what we found looking at the data sets on average across all students, when they have around 70% probability of getting a question correctly, that's when they stay the most engaged. So the content is neither too hard or too easy. So I think that's one aspect. In general, I think the aspect around just personalizing the learning experience makes it significantly more engaging because you're feeling that the program is actually adapting to your individual needs and preferences. And that also just in general drives the engagement. When we look at it from an equality point of view, I think what's really powerful is that we're seeing the students that have historically been lagging the most behind are the ones that are improving the most. So one of the things I'm most passionate about is how we could drive that change with adaptive learning technologies and help the students that have struggled in the past reach new heights.
Okay, great. And I wonder if, Conor, I can ask you a similar question, but building on that, are there particular types of learning that these kinds of personalized technologies are more applicable to, or does it work for all kinds of learning?
Well, first of all, I mean, since the pandemic, this type of learning is becoming incredibly popular. So we're all seeing, we're all incredibly busy at the moment. And I suppose the last time something like this happened, or there was a big interest, we made a big mistake, I think, which was we gave very exaggerated marketing, a very simplistic idea of if we can just find one type of learning that's really effective and then just sort of sell that widely across the world. I think, especially AI in education, we've learned over the last few years that we still don't know a lot about the learning process. So a little bit of that exaggerated benefits have to be tempered with really trying different strategies. So to distinguish what we're really good at from what we're still exploring. What we're really good at is modeling learning. And what we're still exploring really is how that best fits in with how teachers use it. And then different learning strategies. So is it mastery, is it reinforcement? So many of these can be quite effective, but really that area, the whole learning design area, still needs to be explored, validated a little bit more.
Yeah, fantastic. And I wonder if, moving on to a slightly different topic, Jessica, some of what I've always wondered about as a teacher, very difficult, it seems to me, to understand what students know or don't know, can do or can't do. Hard to, and then work out which bits of data will be reliable for those different things. And what's happening now that's enabling us to feel confidence in the way that we're using the data that we have to actually work effectively as something that accelerates learning for kids within a personalized AI environment?
What works effectively is a combination. I think the diversity of the data is speeding up. We can have increasingly different kinds of data that tells us not only what the students are learning in terms of their focus and in terms of how they're understanding the questions and the concepts, but also increasingly then there is talk of how to understand their affective states. And obviously this brings in somewhat of a kind of privacy issue. So as we saw with the pen, then there is a possibility for wearables, and this is a great field which could go further, but we're just not there in terms of finding out how we can use the small microprocessors alone, because we still need the other hardware and software. And it's really difficult to, at the moment, get all of that diverse data in a way, like the social understanding, in a way that, and the emotional understanding that is also taking into account the ethical concerns. Nevertheless, I think at the moment, what is the best way to do it is to have this blended data analytics. So you have, on the one hand, the analytics from the machine learning, from the adaptive learning, and from the AI, and then you have the teachers' know-how, or, you know, in Joel's case, the nurses' know-how, and the pedagogy itself, like what's the actual subject knowledge, but also like the class management and the social understanding of the students. I think what I've seen, at least in terms of the pilots that we've run, is that increasingly there is an absolute need for the parents and the students to communicate with not only the teachers, but also the products themselves. And that's a real question of how do we open that up? How do we have those kinds of inputs from the students and the parents to actually design the products or improve the iteration of the products at an earlier stage? So I think these are some of the important aspects that we need to be looking at in the future.
And then just digging in for a second to the mechanics of this, you know, we've talked about a dream of personalizing learning and education for a long time. We've also talked a lot about technology playing a role in transforming education. But, you know, 10 years ago, 15 years ago, when we said these things, the revolution that we were looking for didn't take place. Are there things that are happening technologically in the mechanics of these platforms that are giving us confidence that actually we will make a step change in the effectiveness of education technology now, or are in the process of doing so? Do you want to take that, John?
Yes, sure. And I think we shouldn't underestimate the kind of effect that this is having on learning and education today either. I think it's having a very significant effect. All of this technologies implemented across a range of products and different parts, ranging from K-12 education to reskilling and upskilling, which we are focused on. I think the challenge has just been that we've maybe been too optimistic on how much that would change the current system. And I think with every new paradigm, you first have to adapt to the existing system and the existing mediums. And that's what I think has been the case to date. We've just digitalized traditional books. We've optimized for the standardized tests and so on. And I think what we'll probably see in the next few years is that the system starts adapting to us. So the schools all of a sudden start asking themselves, how could we rethink our schools as a function of these technologies? And that's something that I'm very hopeful will happen in the next few years. But to date, we've seen dramatic improvements across a wide range of use cases from these technologies. So I think that's being a bit underestimated as well. It was just maybe not as drastic as we had hoped for, but those kind of drastic improvements usually happens when the paradigm starts adapting itself more to the medium.
And just to follow up, are the technologies that we have at our disposal right now more potent than the ones we could have used 10 years ago? Is that making a difference?
Yeah, and I think there are some areas where we've seen significant breakthroughs. So this kinds of products were essentially not possible historically. One is products around reading literacy, the speech recognition technologies that have been developed in the past 5 years are really enablers of that. There are other parts such as grammar. If you think about Grammarly, I mean, that's just an incredibly powerful tool that most of us use every day, but we wouldn't think of it maybe as ed tech. But I know teachers at most schools in Sweden are using it. I know students at most schools are using it, and this is fundamentally transforming how we write. And that's another technology that just wasn't possible 10 years ago because it's built on NLP techniques that were developed more recently. And then there are others, which is more maybe the scaffolding approaches that we have in many of these systems to personalization that I think very much were possible and built more on the expert-based systems approach of the past. But there's been a few of these across natural language processing, speech recognition, and others which simply weren't possible 10 years ago.
Yeah, thanks, Joel. And Conor, Joel reminded me of a point that came up in your presentation, which was around, the role of what you might call the humans in the loop, the teachers, the students, who have certain ways of operating. What is the future for students, teachers, and parents in relation to these technologies? Are we talking about outsourcing learning entirely to personalized AI platforms, or is there a role for the humans in the future?
Well, it's definitely the interface that has been the most difficult. I mean, you asked Joel then which technologies are the most effective. So some of these technologies already are incredibly effective, but are used by, let's say, 1 in 10 product designers. So new learning products come out, majority don't really take advantage of these technologies. And then of those products, 9 in 10 teachers don't use them. So of that, let's say 1 in 10 products and 1 in 10 teachers, I think as the products get more experience, or certainly now with the pandemic, teachers who never really tried these products are exposed and trying them much more. So this adoption, both by product designers and by teachers at the moment, will bring these much more effective products to market very quickly. And I think that's going to have a surprising impact. And then an assumption in the years to come that teachers will demand much more powerful AI products to help them do their jobs. And I think that more than the technology itself might be what surprises you in the next few years.
Yeah, and we have 3 minutes to go before we're going to end the session, before going to the breakout in 15 minutes time. So my question is, and maybe Jessica, you want to start with this one, but we'd love to hear from everybody. What's going to get in the way of personalized AI learning realizing its potential for students? What are the challenges that might prevent it from doing so?
Mm-hmm. So I think the challenges are that the predictive analytics need to be communicated a lot more with the students and the parents. Just as we had previously, without the data analysis, then a lot of subjectivity of the master teachers not liking a student, then we don't necessarily get the same problem with the predictive analytics not liking the student, because it's neutral, but it's this sense of that if a student is struggling and struggling and struggling, then they are deemed at risk, can be profiled by the data. And if the teachers and the parents then take that as is, then without really understanding the social context, then there is a great risk that that student will begin to see themselves as not being able to achieve, and therefore that will affect their performance. And so we really need to help the teachers to understand the predictive analytics, so that it's not just a case of, oh, well, they're predicting this and therefore let's just forget this program altogether. And that intervention needs to happen with a lot more support from, I think, companies that can support the teachers to analyze that data and do training, but not just say, okay, I'm going to dump this kind of technological training on you and, you know, you just have to learn it because we're in the future now. It's more about, okay, what do you know? You have this great knowledge, this great pedagogical experience and all this teacher-based understanding. Let's start there. And what can you teach us and what can we teach you? So this kind of peer-to-peer learning between the companies, the product designers, developers, and the teachers and the students themselves. And it needs to be a lot more holistic. Otherwise, if we don't have that, then that will be a real challenge, I think, in the future, not only for the adoption of the solutions themselves, but also the risks that it causes for the students to be put into profiles that don't necessarily reflect their not only their true abilities, but also the social context of the students themselves. And then that leads on to inequalities, of course. If there are these profiling that's going on and that you have all this data that then shows that this type of student is like that, then it may keep predicting and then we can't get out of it and it's a hall of mirrors. So yeah, a lot of explainable AI is needed. That's not always possible because the weighting of the weighting in the neurons is not always explainable itself. We can't always explain the AI. So that's something that needs to be, I think, developed in the products themselves. How can we build products that do have explainable AI? And that may slow things down a little, but you can always do R&D with an ethical application. I think it's absolutely important for our future.
Thanks so much, Jessica. So we're actually at the end of our time, but I think we've been left with a very powerful thought there, which is that the quality of the products in personalized AI learning are becoming better than we ever imagined, being adopted at a rapid pace right now because users out there are demanding it, and that therefore soon we should expect to see a system that is adapting itself to the quality of the technologies that are available. And I think that's an exciting future. And it's been a great pleasure to hear from the three of you who are very much part of shaping that future. So a really big thank you to Joel and to Conor and to Jessica. And hopefully you can all join us for a discussion in 15 minutes time.